It's really long. All right. So, integral properties and geometry. What integration does, okay, this symbol right here, our integral symbol, okay, is allows us, if I have a function from A to B, all right, what allows us to do, find the area between the function and the x-axis. Otherwise known as the area under the curve. Okay, this is fx. So, now this is specifically called was a definite interval. All right. To give you an idea of what that means is we have what's called an indefinite interval, which is where I don't have any bounds. Here, my bound, my function is between A and B. If I don't have any bounds, it goes on forever. It's an indefinite. Yeah.
Which one is the one that you put like plus C on?
Indefinite.
Indefinite.
So definite integrals, the reason why you don't do plus C is you'll see why. It's really, you won't understand until you see how it works. So, there are some rules. If my lower and upper bound is the same value, what would the area be of that line? 0. There's no area of lines. Lines don't have area. So, equals 0. Now, number 2, what is the difference between my definite integral and the given area of the curve and number 2? Yeah, A and B are switched around. Now, if my A and B are switched around, what that means is it is negative integral from A to B. Now, I could do that forwards and backwards. So, for example, here I can switch this as negative integral of B to A. So, anytime you want to switch your bounds around, just go negative. If I have separate functions separated by a plus or minus sign, I could separate this as the integral from A to B of f of x dx plus the integral from A to B of g of x dx. You want to know? Just speed up. AB is count 1, BC is count 1. So it's faster and we cover a whole lot more.
So much more.
Yes.
So they should have.
Oh, yeah. I wouldn't. And
Okay, that's what I told them, but
honestly, what's going to be the fun part is even if sometimes just because the schedule's going to be real fun, they make you something what they can get into.
they take it for you.
They can, yeah, or they can get on credit.
Oh,
Yeah, I do both.
is this BC?
AB.
AB.
Mhm.
Ah,
So some people are in here, yeah. Some people, they wanted to be in BC, but
yeah.
their schedule wouldn't allow them to be. So.
Good kid. So, all these kids. I'm very happy. Everyone, except for, I don't mind you. But I just give me a rub.
In positive out our inside integral, we can move any type of coefficient outside. So we can write this as k times the integral of a to b of f of x dx. And the integral of a constant, essentially constant, that means that I would have this right here from A to B. C. What shape is this?
Rectangle.
A rectangle. How do you find area of a rectangle?
How you find line?
Well, that's width. Now, here's my width. My length is a difference, so that would just be C times B minus A. So height and width, length and base, whatever you want to call it. It's height and base. Now, from the check problem, okay, it's properly in. So, we are going to look through some of these using these properties. We are given that the integral from a to b of f(x) dx is 5. Integral from a to b of g of x dx is negative. What is the integral from b to a of fx? Negative 5. What's the integral of a to b of 3 of x? 3 times 5, 15. What about the integral from a to b of just 3? Yep.
3 b minus a. 3 times b minus.
Yep. Now for number 4, we can separate this as the integral from a to b of 3 dx plus the integral from a to b of f of x dx, which we notice to be 3b minus a plus 5. All right. So what's number 5?
Negative 1.
Yeah. So 5 plus negative 4 is 1. All right. So what about 6? 5 minus negative 4 is 9. And
Here.
I don't think we covered this one. Wasn't in it is in the properties, but we didn't cover this. If I have the integral, this is right here, so if I have the integral from a to c plus the integral from c to b of the same function, I can combine that to be the integral from a to b. Okay.
That's a c.
So it's just another value. So in this case, I have 6. So the integral from a to 6 plus the integral from 6 to b, I can combine that to be the integral from a to b of g of x dx, since these values are the same. And what's the integral from a to b? Negative 4. Yeah. What that means is if I have a function and I want to find the integral, I can separate it into parts and find those separate areas if I need to. That's really helpful if I have a graph of the function and I have some nice easy shapes like triangles and trapezoids and semicircles and stuff like that. I can separate each of those areas out and add them together. So this is a good question. I think you're going to have a question like this on your test. So if the integral from 5 to 2 of 2f of x plus 3 is 17, what is the integral of 5 to 2 of x? Well, we can separate this out, right? We can write this as the integral from 2 to 5 of 2f of x dx plus the integral from 2 to 5 of 3 dx equals 17. We can write this then as 2 integral from 2 to 5 of fx dx plus, well, what is the integral from 2 to 5 of 3? This is 3 times 5 minus 2, so 3 times 3 is 9. So we can subtract the 9. 2 integral of 2 to 5 f of x dx is 8 divided by 2. Integral from 2 to 5 f of x dx is 4. If f of x is an even function, and you know the integral from 0 to 4 of f of x dx is 6, what is the integral from negative? I mean,
Because if we have a parabola, if it's the same this way, it's this way, so you should add it.
even function means it is symmetrical across the y-axis. But whatever is going to the right of the y-axis is the same to the left. So if my area to the right of the y-axis from 0 to 4 is 6, then the area from negative 4 to 0 is also 6. So that means that we can write this as that this value is equivalent to 2 times the integral from 0 to 4. Yes. So with every even function, if my bounds are from negative a to a, idea here. So if even, well, let's use actual real words. If f of x is even, then the integral from negative a to a of f of x dx is equal to 2 times the integral from 0 to a. This is, well, now what is an odd function? How's an odd, what's the symmetry of an odd function? It has rotational symmetry around the origin. So yeah. Now anything above the x-axis is positive. Anything below the x-axis is negative. So these would cancel out. Yeah. So if f of x is odd, if f of x is odd, then the integral from negative a to a of f of x is 0. Yes. It is 0. So, sure, there's some weird typo here, but it should say each each region defined by the definite integral. I don't know what that's supposed to say here. Use formulas you learn geometry for rectangles, circles, and triangles to evaluate each definite interval. Now, we can draw this out, okay, from 1 to 3. We have x plus 2, that one has 2, that 1 that would be 3, that 4, and 5. So how do we find this area?
Putting the triangle, rectangle.
You can, or you can do trapezoid.
Right.
So trapezoid gives you base 1 is, what is that? 3? It should be 3. Base 2 is 5, and the height between these is 2. So area is equal to 1/2 the height times base 1 plus base 2, which is 1/2 of 2 times 3 plus 5, which is 8. Well, that's why you want to do it, because it's faster than doing 2 separate shapes. Sometimes, I guess you could make 2 separate shapes. If you do the 2 separate shapes, which again, would it be fine if I made this a rectangle and triangle and know this is 2 times 3, so 6, and this is 1/2 of 1 times 1/2 of 2 times 2, so this would be 2. It's just not a very good drawn out triangle shape there. What kind of shape is this?
One that is not nice.
It's not such a thing. All right, so we'll go from -3 to 3. So what do I get if I plug in -3? 0. If I plug in +3, I get what? 0. If I plug in 0, I get 3. Yeah, it's a semicircle. How do you find area of the circle?
Oh.
Well, area of the circle is just pi r squared. Half of that is, yeah, 1/2 pi r squared. What's my radius here? 3. So 1/2 of 9 pi, or 9/2 pi. There you
Squared.
go.
And that's squared.
Yeah. We do want to separate this out to be the integral from -2 to 0 of 1 dx plus the integral of -2 to 0 of the square root of 4 minus x squared dx. Now we kind of already know this right here is a circle, but is it a semicircle? No, it's what? It's a quarter of a circle. Okay, so this is going to be 1/4 pi r squared. My radius is from 0 to 2, so my radius is 2, so 1/4 of pi times 4, or just pi. What is this area?
How'd you know it was a quarter?
Because it doesn't go from -2 to 2, it goes from -2 to 0. So that graph would look like that. Also, just because I've been doing it a long time. What is the area of this little section? The constant, it is that value times the difference between a and b, so 0 minus a -2. So 1 times 2 is 2. So my total area would be 2 plus pi. All right. Number 4, linear function. Linear functions are nice. So we start at 4. 1, 2, 3, 4. We're going from -1 to 3. So -1 would be 5, 3, 2. So again, not a trapezoid, but if you want to make that a rectangle like a triangle, go right ahead. We have a height of 1, so this area is just 4. We have 1, 2, 3, 4. 4, 1/2, 4 times 4 is 8. So it's 8 plus 4. Oh. Yes.
So for these, maybe this is like, doesn't work or anything, but I was seeing a shortcut where you could just like chop off the top half of the triangle and then like fold it over so it's just one big rectangle, it's the same area.
Yeah, you can do that. I mean, like, and that makes sense. So you could take this section here and move it over
Yeah.
here.
That would be.
Yeah.
Okay.
So that would give you still an area of 8 because this is 2 times 4, so that would be.
Well,
It's a really thing about this.
The height by half bigger.
You can also do 1/2 of height times base 1 plus base 2, which gives you the height here is 4, so 1/2 of 4 times this is 5, and this is 1. 5 plus 1, so 2 times 6 is 12. So yeah, many ways to do this. And what about this one? Now, this is your value from -2 to 2. That's the value of x plus 4. So 0 would give you 4. 2 would give -2, and both +2 would give you 6. Now, what kind of function is this? It is an even function, so you could just find this area and then double it. So again, if you wanted to do this, make that rectangle here, you could. Okay? So this was what, 1, 2, 3, 4, 5 times 2, so 10 and 10 would give you 20. What kind of function is number 6? Graphically, let's look at this. So we're going from -5 to 5. I'm not going to go all the way to that. But 1, 1, 2, all the way to 8. Yeah. -1, -1. Actually, that line there. So it looks like. So I want this area and this area. What do I know about these two areas? They're equal. This is an odd function. And what do I do if I go from -a to a, an odd function?
0.
0. Cancels out. Because it's not a function. So negative area, positive area. Here, yeah. Yeah. We can stop here. All right. It's not homework.
Wait, how did you do 5?
Yeah, you can do these in your car.
How did you do 5?
You're going to teach us or try to Google it, huh?
No. What?
How did you do 5?
I just use Boston, but it's a rectangle by with solid area.
Just like the triangle part, it's 2.
Yeah.
When we split it on the front,
Yeah, I just made it rectangle.
split in half, half the height, multiply.
What's your days?
Oh.
4. How did you get that shape? Travis, on this,
Number
so you got it.
4.
Yeah, it's like you got the initial traps on.
How to get the
Just like the initial traps, but you gotta do that shape.
well we go from -1 to 3, so -1 to 3.
Oh, but you want
And I just plug in the value, draw my line, and then connect to the x-axis.
Oh, okay, so you're just
Yeah.
4 minus -1.
Yeah, this name.
Yep, because you plug through, yeah.
And then he was.
Alright, so we are gonna look at tomorrow,
Be like, oh my god.
finding areas given graphs. So, yeah, which I might as well go and show you this because it's not that big a deal. Okay. Well, in fact, we'll use this one right here, just to show you that how you can do these on a calculator. That's mine, you're gonna learn anyway, move it up. So if you have your calculator, if you go to math, you know how we did derivatives? Okay, if you go one more down, if you go to 9. It's 9?
Almost fine.
It's this one. It's math and then 7, FNINT. So finite integration. Should be right after derivative. So it gives you that, and then you just type everything in. So we went from what, 3, -1 to 3, so 3 and -1. So we have 4 minus x. And then 12. So yeah. Alright, this only will do definite integration. So anytime you have definite integration, you can plug in calculator. And feel free to do that. Okay. It's the indefinite integration is the fun question. Okay. We'll read it. You know what I'm like,
It is now synonymous with
you know.
Yes, he reads interest. Yeah, he reads it.
you.
So we'll finish up day 1 of March. Just 2 pages left. Really won't take long for you time to get the homework done. So, and then we'll look at indefinite integration. How would it feel?
I really. Oh, yeah, I'm going to. Oh, yeah, it's good. Let's do it. Other than what for this stuff, imagine. And there's no.